number 21. So students at Woodrow Wilson High School are always one letter followed by 5 digits. I said students, it's the IDs that are one letter followed by 5 digits, and they tell us that the digits may repeat. So they give us an example, and the student ID is V00127. They want to know how many unique IDs are possible under this system. So this is a combination or permutation problem. I tend to do these in a potentially simplified manner. So I like to sort of, using these underscores, or what I call slots, I sort of like to lay out what I'm dealing with for a little bit of a visualization. So they tell us that it's one letter and then it's followed by 5 digits. So 1, 2, 3, 4, 5. So effectively this is digit 1, this is digit 2, this is digit 3, this is digit 4, and this is digit 5. Oops, that's supposed to be a 5. Okay, good. So now I like to start to think about this in the sense that how many letters can I choose from? So the letters has a pool, and since we're pulling from A to Z, there are 26 letters in our alphabet. So if I was thinking of how many letters I could choose, well, I can choose from 26. Great. Now, when we are dealing with our digits, we are able to choose from the digits 0 through 9. Well, if we do 0 through 9, that is technically 10 numbers. 1 through 9 is 9, but since we're including 0, that is 10. Your answer choices kind of also help if you don't count by hand. So for the first digit, I have a pool of 9 options. So, whoops, I said 9. It was on my brain. I meant 10. 10 options, right? 0 through 9. So I can pull from 10 numbers. So I can say that there's 10 choices, right? Either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, if the letters couldn't repeat, then my next choice, I would only have 9 options. But they give us this statement that the digits may repeat. So since the digits may repeat, our values are not going to be reducing each time. So that means that for digit 2, we still have 10 choices because, again, our digits can repeat. And then that's going to be the same for each of these digits. There's going to be 10 choices for each of them, and they're not being reduced, and they're not being reduced each time because the digits can repeat. So due to, in combinations and permutations, we talk about the fundamental counting principle, which states that if there are m ways to do one thing and n ways to do another thing, then there are m times n ways of doing both, and it's going to be multiplication. So if we multiply all those together, they want it in simplified form, and they want it simplified using exponents. So that is going to be 26 times 10, and since it's 10 times 10 times 10 times 10 times 10, that's 10 to the 5th.